Hello friends, myself Dr. Nandakumar Raubole from College of Engineering Ambajogai is going to deal with Applied Thermodynamics 2. This is our 11th lecture. In previous lecture, we have discussed the actual vapor compression refrigeration cycle and effects of various parameters on system performance. Today we are going to discuss the refrigerants, classification of refrigerants, designation system for refrigerants, secondary refrigerants, properties of refrigerant, and selection of refrigeration. So these two last points, properties of refrigerant and selection of refrigerants, we have discussed in detail in lecture number 5. Now, what this refrigerant is? A refrigerant is a working substance used in a refrigeration system to absorb heat from a space to be cooled, which is at a lower temperature than surrounding, and to reject heat to surrounding, which is at higher temperature. That is nothing but we want to cool this space, and in order to cool this space, so the heat from this space has to be absorbed by this substance, and that heat which is absorbed by substance has to be rejected to surrounding, so that the same refrigerant can be reused. That is nothing but the refrigerant. Refrigerant is a working substance. It is a substance used in a cycle, then used in a refrigeration cycle to absorb heat from where? From a space which we want to cool, then which is at a lower temperature than surrounding, and our aim is to reject that heat to surrounding, which is at higher temperature. So that substance is known as a refrigerant. Now the refrigerants are classified broadly into two groups. Number one, the refrigerants are classified as a primary refrigerant and secondary refrigerant. What is this primary refrigerant? The refrigerant which directly takes part in refrigeration system are called primary refrigerants. That is nothing but these are the substances which directly absorb heat from the space to be cooled below the surrounding temperature or to the desired temperature. Such refrigerants are known as primary refrigerants, whereas secondary refrigerants are those which absorb heat energy from the primary refrigerants and reject it to the surrounding. So the refrigerants which are cooled using primary refrigerants and used for cooling purpose are known as secondary refrigerants. So these refrigerants are cooled by the primary refrigerant. That means secondary refrigerant carry the heat from the space to be cooled, and that heat is given by the secondary refrigerant carry the heat from the space to be cooled and transfer it to the primary refrigerant. So this is how these refrigerants are working. So now primary refrigerants directly absorb heat from the space to be cooled, and the secondary refrigerants are absorbing heat, the refrigerants which are cooled by using primary refrigerant. So those are secondary refrigerants. So now we will see the classification of primary refrigerants. So primary refrigerants are further classified into 4 categories. First one is halocarbon refrigerants, then Azure Drop refrigerants, inorganic refrigerants, hydrocarbon refrigerants. So now what these halocarbon refrigerants are? So halocarbon compounds are synthetically produced. These halocarbon refrigerants are developed as a freon family, and the first halocarbon refrigerant, that is designated as R12, was developed in the year 1930. So the examples of halocarbon refrigerants generally used are trichloromonofluoromethane. These are the chemical compounds which is designated as R11. Then dichloro difluoromethane designated as R12. Then monochlorotrifluoromethane designated as R13, and carbon tetrafluoride designated as R14. And there are so many refrigerants which are known as halocarbon refrigerant. There is a large list of halocarbon refrigerants. Now second category is azeotrope refrigerants. What these azeotrope refrigerants are? So generally two kinds of refrigerants are mixed to obtain azeotrope refrigerants. In short, we can say these refrigerants are as hybrid refrigerants. So the vapor and liquid phase retain identical composition over a wide range of temperature. So such as water. So if water is in the solid form, just ice, or it may be a vapor, or it may be a liquid, so its chemical composition remains same, that is H2O. Similarly, in azeotrope refrigerants, the vapor and liquid phase retain identical composition over a wide range of temperature. Whatsoever is the temperature, or over a long range of temperature, it remains constant. It does not change its composition. And these are such as R500. R500 is azeotrope refrigerant which consists of 73.8% of R12 refrigerant and 26.2% of R152 refrigerant. Then second is R502. So R502 refrigerant is an azeotrope refrigerant. This contains 48.8% of R22 refrigerant and 51.2% of R115 refrigerant. Similarly, R503 contains 40.1% of R23 and 59.9% of R13 refrigerant, and R504 is the mixture of R32 and R115 in the ratio of 48.2% and 51.8%. So these are nothing but hybrid refrigerants. Now we go for inorganic refrigerants. So inorganic refrigerants were used before introduction of halocarbons. So now what are the examples of inorganic refrigerants? So ammonia is one of the inorganic refrigerant. Air is another inorganic refrigerant. Carbon dioxide, inorganic refrigerant. Sulfur dioxide is a inorganic refrigerant, whereas water is also one of the inorganic refrigerant. Now we see next category, that is hydrocarbon refrigerants. So what these hydrocarbon refrigerants are? So hydrocarbon refrigerants are chemical compounds consisting of hydrogen and carbon are known as hydrocarbons. Then what these hydrocarbon refrigerants are, we know now. Where these refrigerants are used? Hydrocarbon refrigerants are generally used in industries for commercial purposes. So example of hydrocarbon refrigerants are ethane, that is R170, propane R290, then butane R600, isobutane R600A, and ethylene, that is R1150, etc. There are many more hydrocarbon refrigerants which are used in a refrigeration system. Now we will see the designation system for refrigerants. Till now we have seen the designation of refrigerants as R22, R12, R15, R11. What this R and number indicates, how these refrigerants are designated, that we will discuss. So the refrigerants are designated as R followed by certain number. For example, R12 and R114. There may be R600, R500. What these are, that we see. So the refrigerant followed by 2-digit number represents methane base. So if we have R12, that indicates it is a methane base. If it is R114, then it is the refrigerant followed by 3-digit number represents ethane base. It is ethane base. So this is R12 is methane base, R114 is ethane base. Then first digit on right side or right is the number of fluorine. So here R114, so this first digit 4 is fluorine. So R12, again 2 represents as a number of fluorine atoms. Then first on the right represents fluorine. Then second digit from right is 1 more than number of hydrogen atoms. So here second digit is 1, here second digit is 1, so it is 1 greater than number of hydrogen atoms. Say for example hydrogen atoms are 0, then 0 plus 1 is 1, so this is 1, this is 1, that means there is no hydrogen atom in these two compounds. So second digit from right represents 1 more than hydrogen atoms. So first digit is fluorine, second digit is 1 more than hydrogen, and third digit from right is 1 less than number of carbon. So if there are 2 number of carbons, so this is 2 minus 1 is 1, that is R114. So first is fluorine, second one is 1 larger than hydrogen atoms, then third digit is 1 less than carbon. So third digit is 1 less than carbon. If carbon already is only 1, 1 minus 1 becomes 0. If it is 0, then it is not represented, it is omitted. When third digit is 0, it is omitted. So this is how the refrigerants are designated. We will see certain examples. So then the general chemical formula for refrigerant is given as CM, HN, CLP, FQ. So C represents for carbon, H represents for hydrogen, Cl represents for chlorine, and F represents for fluorine. So in which N plus P plus Q must be equal to 2M plus up to where this M is number of carbon atoms. M is number of carbon atoms. Then second one, N, where N is number of hydrogen atoms. N is number of hydrogen atoms. So here N, here N, here N. So this is number of hydrogen atoms. Then 5, P is number of chlorine atoms. Number of chlorine atoms. P is number of chlorine atoms. So here P and here P, purple color. Then Q is number of fluorine atoms. Q is number of fluorine atoms. Q represents number of fluorine atoms. So here Q is number of fluorine atoms. Then the number of refrigerant is given by R. R is always there. M minus 1. M is nothing but number of carbon atoms. So M minus 1. And N plus 1. N plus 1 means number of hydrogen atoms plus 1. And Q is nothing but fluorine atoms. So fluorine is Q is nothing but fluorine atoms which are present in this refrigerant. Then we will see one example. And let us take a designation of dichloro-difluoromethane. Dichloro-difluoromethane is designated as a chemical compound CCl2F2. So CCl2F2, we compare with the standard general formula. So comparing chemical formula with general formula, that is CmHn ClP FQ. So what is the value of M, what is value of N, what is value of P, and what is value of Q? Say M, number of carbon atoms here is 1, only 1. C1 is not represented. C means only 1 atom. So M is equal to 1. So here M means nothing is written here. So C is only CCl2F2. So C1 is nothing but M value is 1. The next one, number of hydrogen atoms. So this does not contain any hydrogen atom. N value is 0. Then P, number of chlorine atoms is 2. Chlorine atoms is 2 here. So P value is 2. P value is 2. Then fluorine F2, Q value is number of fluorine atoms is 2. So you can see here fluorine is 2F2. That is nothing but value of Q, number of fluorine atoms is 2. Now whether it satisfies the condition or not, that we see. So what is the condition? N plus P plus Q must be equal to 2M plus 2. So N value is 0, then P value is 2 and Q value is 2. So 2 plus 2 plus 0, this is 4, and on right hand side we see here 2M. M is 1. 2 into 1 plus 2, that is again 4. Left hand side is equal to right hand side. So then we can designate it like this. The number of refrigerant is given by R M minus 1 N plus 1 Q. So R is constant. M value we know. M value is 1. 1 minus 1. Now we are replacing this M by 1. 1 minus 1. Then N plus 1. So this N plus 1 we are replacing as 0 plus 1 because N value is 0. So N value is 0, you can see here. So 0 plus 1. Then Q value is 2. So 2 here. Now simplification of this one. R 1 minus 1 is 0. 0 plus 1 is 1 and 2. So R 0 1 2. R 0 1 2. So here it is given that if third atom becomes 0, that is omitted. So R012 is written as R12. R12 is nothing but the designation for dichloro-difluoromethane, which is used as a refrigerant. Now second refrigerant we take here, dichloro-tetrafluoroethane. Dichloro-tetrafluoroethane. So now here dichloro-tetrafluoroethane. Now we compare this formula with a general formula, that is CmHnClpFq, where M is equal to 2. Now you can see here carbon atoms are 2. In previous case it was 1. So M is equal to 2. Then second one is hydrogen atom. Here we do not find any hydrogen. That means N value will be 0. So number of hydrogen atoms is again 0. Then third one is ClP. P value here is equal to 2. So number of chlorine atoms is 2. Then Q, number of fluorine atoms. Fluorine is Q is 4. Then whether it satisfies this equation or not. N plus P plus Q. N is 0. P is 2 and Q is 4. 0 plus 2 plus 4 is 6. Then M into 2. M value is 2. 2 into 2 is 4 plus 2 into 2 is 4 plus 2 is 6. So left hand side is equal to right hand side. It satisfies this condition. Then number of refrigerant which is given by R M minus 1 N plus 1 Q. So now M value we know, that is 2. That is 2 minus 1 is 1. N plus 1. N value is 0. 0 plus 1 is 1. And Q value is 4. Means 1, 1, 4. Now we can see here 2 minus 1. 2 is nothing but value of M. 2 minus 1. Then N value is 0 plus 1. 0 plus 1. And Q value is 4. Q value is 4. So here R 2 minus 1 becomes 1. 0 plus 1 becomes 1. And 4 becomes 4 as it is. So that is R114. It is designated as R114. This is how the refrigerants are designated at international level by using this scheme or this system. Now we will see what is a secondary refrigerant. So as I told you, the refrigerants which are cooled by using primary refrigerant. So primary refrigerants are going to carry heat from secondary refrigerant. That is, the refrigerants which are cooled using primary refrigerants and used for cooling purpose are known as secondary refrigerant. So these secondary refrigerants are brines are secondary refrigerant. What is this brine? Brine is nothing but one kind of solution. What it consists of? Brine is a solution of calcium chloride or sodium chloride with water. So calcium chloride plus water or sodium chloride plus water is known as a brine. But generally this brine has got chemical reactions with the metals and it corrodes the metal, so it is sometimes avoided. So what happens here, the freezing point of water is 0 degrees Celsius, say. If we add sodium chloride to water, then freezing point of water gets reduced. Instead of freezing it at 0 degrees Celsius, it gets freezed at minus minus temperature. That may be negative temperature. It may be 5 degrees Celsius, 10 degrees Celsius, 20 degrees Celsius, depends on the concentration of salt. So if higher is the concentration of salt, then the freezing point of such brine is going to reduce, and if sodium content is minimum, then the freezing point is maximum or it increases. So that is nothing but the brine solution. So sometimes this brine has got reactions with the metals, therefore it is avoided to some extent. So instead of that, we have some other solutions, that is ethylene and water solution, then propylene glycol and water solution. So these ethylene, propylene, glycol are known as anti-freezing elements, which are added to water, which reduces freezing tendency of water, or it reduces the freezing temperature of water. So these substances are known as secondary refrigerants. Then already we have discussed these physical properties of refrigerants in lecture number 5 in detail. So here just we will see briefly what are physical properties of refrigerant, that is low freezing point, then low condensing pressure, high evaporator pressure, high critical pressure, high vapor density, high dielectric strength, high latent heat of vaporization, and high heat transfer coefficient. Then some other physical properties are a low boiling point temperature, then high critical temperature, low specific heat of liquid, low specific volume of vapor, non-corrosive to metal, then non-flammable substance, non-explosive substance, it should be non-toxic, then low cost or cheaper, then easy to liquefy at moderate pressure and temperature, then easy to locate its leakage by using odor or suitable indicator, then mix well with oil, which helps for lubrication of compressor. Then which refrigerant is known as an ideal refrigerant? What refrigerant is called as an ideal refrigerant for using it as a refrigerant in a cooling system? So it should be non-explosive, it should not be inflammable, then it should be relatively cheap, then it should not be poisonous, it should not give discomfort where gas leaks to the outer air, then easily available, and it should be of such nature that gas leaks are easily located by smoke tests or similar methods. So if all these properties are present in a refrigerant, then such kind of refrigerant is known as a ideal refrigerant. Then how the refrigerants are selected? Based on certain factors. What are the factors for selection of refrigerant? So there may be many more factors. So out of that, 5 factors are considered for selection, that is performance of refrigerant, then safety, and then reliability, and environmental acceptability, and finally simple economics. So if a refrigerant possesses these good qualities in it, then we used to select it. So depending on performance, whether the refrigerant gives good performance, or whether a refrigerant enhances the COP of refrigeration system, and whether it is safe to use, and whether the refrigerant is reliable. That is nothing but the properties of refrigerant should remain constant or will not change, should not change haphazardly. It has to follow certain law to change its property. Then we will say that such type of refrigerant is reliable. Sometimes the environmental acceptability, if the refrigerant leaks out, it should not harm to occupants as well as ozone layer. or any other environmental issues it should not create. Then it should have simple economics, means it should be cheaper and easily available. So if a refrigerant possesses these factors, then we used to select the refrigerant. So this is how we have covered the refrigerants in this lecture. So please refer lecture number 5 for some of the points which I have highlighted. So these points which we have seen in lecture number 5 are starting from this physical properties of refrigerants. So these points we have discussed in detail in lecture number 5. So thank you. We will start the vapor absorption refrigeration system in next lecture. Thank you.